My name is Jim Cluck. Currently I'm a product manager back in New Berlin, Wisconsin in the drives division. So I've been with ABB for 5 years. I was also an application engineer for 4 years prior to moving into product management, and been working with other various drives companies before that. So I've got about 13 years of experience. Just to give you the concepts, the ideas, things to think about when looking at installations with drives. Again, the overall requirements, things to keep in mind. There's always that ideal situation where you've got the correct temperature, the right humidity, the cleanest environment, but in reality we're not always installing drives in those situations. We're installing them in areas where there's rain or dust or debris or environmental issues, chemicals, explosion-proof areas, things like that we need to take into account. So some of the topics we're going to cover today is mounting location, again looking at the mechanics, things like altitude and humidity that come into play, enclosure types, and providing cooling or even heating if need be, if it's a cooler environment. We'll look at flange mounting, what that means, installing drives in those situations, the surface type, making sure it's a good adequate surface for mounting the drive to, spacing around the drive if need be, for cooling, orientation, how the drive's going to be installed, things like vibration and shock that come into play. Also, we're going to take a little bit of a look into electrical considerations, wiring practices, networks, things like that. And then at the very end, provide you with an installation checklist. A checklist you can use that we have posted on our website that kind of runs down from, again, from the input power to the output to the motor, and everywhere in between what you need to go through as you're, again, specifying, installing, or using drives. And again, the drives user manual and our documentation and literature that we provide, we're going to try and provide you with the most information on what to do in certain situations for altitude or temperature, derating guidelines, to help give you, again, the best practices for installing the drive to prolong your life, as well as to give you a trouble-free installation. When we look at altitude and humidity, all our drives have been designed around a rating of up to 3,000 feet or 3,300 feet above sea level. You can go to higher altitudes, but you need to look at each drive individually as well as look at the derating guidelines that we give you. As you get higher up in altitude, the ability to cool the drive diminishes, as well as the creepage clearances, the spacing between electronics within the drive diminishes. When you get up there, there's a potential for an arc to occur because the air is broken down. There's not as much insulation between conductors. And again, we'll have a standard D rate. If you look in our technical guide or if you look in our user manuals, as you get to certain distances, we'll give you a D rate on how much you have to derate the drive to install it at the higher altitudes. When looking at humidity, all drives are rated up to 95% condensing, or non-condensing I should say. If there's an issue where you've got high condensation, you may need to add an air conditioner or a dehumidifier to remove some of that. Looking at temperature and cooling, all our drives are going to be rated from 5 to 104 degrees F or -5 to 40 degrees C. When looking at that, you have to take into account both extremes there. You have to look at, is it going to be too hot of an environment or is it going to be too cold? And we'll also provide you with shipping and storage temperatures as well. But again, as you get into hotter temperatures, you may need to derate the drive so that the heat sink and the fan can adequately cool it if the ambient temperature is too hot. And we're not just talking, if the drive's inside the enclosure, you have to take that into account as well as outside. Is there a situation where it's being put in direct sunlight, or if you've got a very extreme outer temperature that's very hot? So you need to take those all into account when looking at the temperature. Again, and also making sure that there's not too big of a swing in temperature so that condensation can't form or moisture can't form, which would be very bad for the electronics. Looking at the enclosure types, there's different categories or different ratings. There's NEMA, UL, IEC specs that all are designed around where the drive's going to be installed. Typically a NEMA 0 or IP00 is considered an open style drive, where you've got exposed terminals, exposed electronics possibly. That's one where you'd want to install that in a cabinet to make sure that it's, again, finger safe, away from users or people that could potentially touch the electronics. NEMA 1 or UL Type 1, again, protected against objects and finger safe, indoor rated only. NEMA 12, adding a degree of protection for dust or contaminants, particles in the air, as well as light spray or drip proof. Going to NEMA 3R, again, outdoor, protection against rain and sleet, in those types of conditions. Typically in those types of drives you have to take into account sun loading and sunspots, making sure, does the cabinet have a sun shield on it? Do I need to install a sun shield? Is the temperature going to be cold? Is it Minnesota and you've got to deal with cold temperatures in the winter, so you may need to add heaters? Or is it out in the desert, in Arizona, and you may need to add air conditioning or cooling or additional fans to make sure that it's being properly cooled. And then we do have some NEMA 4 or NEMA 4X products. Those get into washdown or waterproofed sealed drives. Again, used in the food and beverage industry, or can be placed outdoors. One thing you have to make sure of is if it is an outdoor situation, that the NEMA 4X that you're using is rated for UV protection as well. Sometimes you'll have plastics on it that may not be able to handle the UV rays, may degrade over time. So looking at some of the enclosure styles that we offer, again, you've got NEMA 1 up on the right hand side there, NEMA 4X on the left hand side, a NEMA 3R, you can see where it's got the vents on the left hand side to let fresh air in the bottom, hot air out the top. And then NEMA 12, where we've got standard wall mount or even floor standing enclosures for the larger drives in the NEMA 12 or IP54 enclosure rating. When we talk about flange mounting, we're talking about, there's two real main parts of the drive side. There's the control side, and then there's the heat sink. The heat sink is there to just do that. It's to dissipate heat that's being generated by the IGBTs or the semiconductor devices that are turning on and off. And what you want to do is dissipate that heat. With the flange mount, you can take the heat sink, put it outside of the enclosure, dissipate the heat outside of the enclosure, just have the control section inside of it. It maintains the clean environment for the control section, cooler environment. It allows you to have a smaller cabinet and fit more into it. So in doing so, you just need to make sure, again, on the outside, that if there is a possibility for dust or debris to build up on the heatsink, you're going to still want to make sure that you clean it off or have a good preventive maintenance program to make sure there's not stuff building up on top of it, because it still is being used to dissipate the heat. With that, the heatsink itself is about 80% of the total watts loss that the drive is going to generate, so it's a big chunk of heat to get out of an enclosure. Surface mounting. Again, taking into consideration where is the drive going to be mounted, what is it going to be mounted on, making sure it's a good structure for the size of the drive you're going to be using. If it's a smaller micro drive, you're usually mounting it on a panel or DIN rail. But as you get to larger drives, you get to the 150 horsepower wall mount drive, it's to be a very heavy drive. You don't want to be mounting it to drywall or some weaker plastic structure or something like that. You want to have a good substantial cabinet or concrete wall or even unistrut to kind of hold that in place. And in doing so, you want to make sure that, again, you have a dry, clean surface that you're mounting it to, and that you take into account the airflow that's going to be around it, making sure that there isn't an opportunity for hot air to circulate back into the fans or back into the heatsink. Depending on the style drive you select, if you're using an open and installing it in a cabinet, using one of our U4 or O4 modular drives, installing it in a cabinet, you may need to install baffling to make sure that the air flows in the correct location. Spacing. Again, looking at the space requirements around the drive when installing it, making sure that there's adequate spacing on the sides or top or bottom. Some of the drives are designed where you don't need to have any spacing on the sides. They're called zero stackable because they're designed so that the airflow is from top to bottom. So you can put them right up next to each other and not have to worry about heat being dissipated out the sides. Some of our other drives, though, do have clearances that need to be kept on the sides. Again, looking at our documentation and our user manuals for the different products, you'll see what those requirements are to make sure you've got free space around them to adequately cool them. One thing that's often overlooked is, again, not just the drives, but what are you putting below the drive, or what are you putting right above the drive? Are you putting a large transformer right below it? Are you putting a reactor? You know, those are big heat generators that give off a lot of heat. If that's being sucked up into the drive's fan, going to the drive's heat sink, that's just going to heat the heat sink up, and then you can run into issues with overheating the drive. So you got to take a look as well as not with just the drive, but what's being installed around it. On the topic of orientation, sometimes you don't always have the capability to mount them vertically. All drives are basically designed to be mounted in a vertical configuration, but we have done some where we would lay them on their back or on the side, depending on where they're being installed. In mining applications, if they're putting on, on a car or something like that, something where it needs to be laid on its back, what we want to do is make sure you give application engineering a call. They can take a look at the installation and then let you know if you need to do any kind of a derating, provide an air conditioner, add additional cooling, things like that when orientating a drive in a different manner other than vertical. Vibration, again, where is the drive going to be mounted? Is it in an area that may be seismic? Is it going to be mounted on a piece of moving equipment? Is it on a rail car, or is it on a ship, or is it on the back of a flatbed truck or something like that? With those types of situations, there can be a lot of shock and vibration. You need to take into account the mounting that's done with that. Do I need to involve some sort of shock absorption mounts or vibration mounts when installing that? We do test our drives. We do have the ACS 550 and ACH 550 where we have done seismic testing, where basically they put it on a table, they run it through a sweep of tests, shaking it in different directions, making sure that the drive doesn't fall apart and it still operates based on the degree of potential that could be seen. With that, we get a certain classification that says we're a seismic certified product and can be installed in earthquake zones. One area that we also do is marine approval. Well, we can offer marine certified drives to the different standards, where we've had them designed to be mounted on a ship in certain locations depending on the amount of shock. If they're mounted on the hull of the ship or are they on a piece of equipment, there's can be a lot of vibration and shock that can occur out at sea on ships. So again, if you're looking for something like that, contact Application Engineering. We can tell you what products we have that on and how to get those. Okay, electrical considerations. Again, taking into account the operating network that the drive is going to be installed on, making sure that you know the voltage that's going to be used and the tolerances. If it's going to be used on a UPS or a generator, or is it on an ungrounded distribution system, those all need to be taken into account. Knowing the voltage tolerances that the drive is rated for. Fuse protection. What's recommended? Again, we list all the fusing that we recommend in our user manuals, so you can select those. Are there power factor correction caps installed on the network? They don't mix very well with drive. The switching in and out of power factor correction caps can cause damage or have a ringing effect within the drive. So we want to make sure that you talk with the supplier and either add a reactor or isolation transformer or completely remove them from the system. Seeing you're installing the drive, it's going to increase your power factor. Are there voltage transients? Are you in a location where you experience a lot of lightning or power quality issues? Things like that need to be taken into account. And then installing, effective mitigation devices, using a line reactor or installing a drive with a DC link choke or link reactor, or going to a transient voltage suppression device. Most of our drives are all built with what's called MOVs. Those will help absorb a number of those voltage spikes that you can see on your network, but you may need additional protection. Looking at the input power, again, we talked a little bit about the type of transformer supplying it. I mean, the preferred transformer secondary supplying the drive is going to be a solidly grounded Y-type transformer. That way you don't have to deal with voltage imbalances that can occur with a corner grounded B-type or a high resistive or an ungrounded distribution system. Cable sizing, we want to make sure you're looking at, again, all applicable codes, not just necessarily NEC, but looking at if it's international codes or looking at local codes to make sure you're sizing your conductors appropriately, that you're using the correct branch circuit protection, things like that. Also taking into account voltage drops due to long cable distances. Do you have a lot of cable distances from the transformer to the drive? You want to make sure you take that into account because there could be a voltage drop there. You in turn starve the drive for voltage. You in turn starve the motor for voltage. You may not get up to full speed. And then again, the size of the conductors that are going to be used based on the ambient temperature. If it's in a warmer environment or a hot environment, you may need to take into account using a higher degree C cable wire. On the output section, you want to select a cable that's rated to handle the current and voltage, but also there's differences that come into play with the output switching of the IGBTs on the output of the drive. So you want to make sure that you're handling the output of the drive in the correct manner. Things like reflected wave or common mode current and voltage that occur. You want to make sure that you mitigate those or taking into account, what is the cable distance between the drive and the motor? Am I using a shielded cable? Do I have a solidly grounded ground conductor bringing any noise or currents back to the drive? Again, because we want to avoid any currents getting into the ground plane and affecting any sensitive electronic equipment, PLCs or sensors that may be in the plant. Again, providing shielded around the outside, bringing that noise back to the drive. How is this achieved? You can use an armored cable, a shielded cable, or you can use single conductors in a conduit. Again, you want to be able to have the three phases, a solid ground conductor, as well as a shield. You can use the conduit as a shield, but it has to be a continuous solid path back to the drive from the motor, and you want to make you have a good connection at each junction. So if there's a junction box or if you've got splits in the pipe, you want to make sure you have a good 360-degree contact there to give you the path of least resistance back to the drive. CE requirements, or EMC, if you're, again, in an installation where you need to take into account EMC requirements, for those types of installations we do provide additional data in the user manual. Things about using filters, EMC filters, depending on where you're installing it. Is it a residential area? Do we need to use a more restrictive environmental filter or a second environment filter if we're installing it in commercial or industrial applications? And then the type of cabling that's used. EMC is typically going to require you to use shielded cable on the input as well as on the output, again, to try and help minimize the conducted and radiated noise that occurs. Okay, separating conductors, again, spacing. We're always trying to avoid mixing your control cables with your power cables, making sure you've got adequate spacing between them. You don't want the cross coupling to occur. You don't want to have induced voltages in your control cables from your 480 volt line or your motor cables. Again, we'll provide you with the spacing requirements from control to motor, or control to input power, or even motor and power cables in our user manuals to make sure you're following those. If you're installing them in a raceway or inside of the cabinet, those are all areas where you'd want to, take that into account. And again, if you always have to crossover control with power, you want to make sure you do it at a 90-degree angle. You want to avoid long runs of having your control right next to your power cables. So those need to be taken into account when doing that. So again, you never want to run in a conduit or raceway with power wiring. Again, 120 volt wiring needs to be taken into account. You don't necessarily want to be mixing that with your analog signal or your digital signals. Again, the recommended installation would be one conduit for power in, power out, 120 volt control, and then all other communications are controlled through the other conduit. One other thing is that sometimes people use 230 volts through output relays. They may be using it on a sensor or some other type of device or relay or solenoid, making sure you take that into account, that higher voltage potential. Looking at control cables, again, what type of control cables should you be using? Again, these are your control signals, things that are helping you run your application. You want to take into account making sure that they're of the right type, that can handle the voltage, are routed correctly, and provide shielding. We'll recommend using shielded cable for analog signals, digital signals. Again, using shield for encoder signals, making sure, again, you've got protection from outside noise that's being transmitted or conducted from getting into your control cables. Typically we'll recommend a Belden type with a twisted pair that comes with a shield, or even individually shielded conductors depending on the cable. Landing those and using them with field bus, again, what you want to do is try and minimize the exposure. So when you're installing your control cables or even your field bus cables, you want to make sure that the point from which you cut the shield and the outer wrap back is as minimal as possible. Tie the shield to the module or to the source end depending on the installation. And then following the protocol specific recommendations for Profibus or DeviceNet or Ethernet. They'll have specific type of cables with specific resistances and that they'll recommend. And then also terminating. Make sure you take into account terminating. Which location you're supposed to be terminating. Is it at the beginning? Is it at the end? Do I have points on my control net line that I need to have a tap on? Things like that need to be taken into account as well. On the motor installation, we've touched on a little bit the distances between the drive and the motor, things that can occur there. As you've got longer cable lengths, you get capacitance that can build up between the conductors themselves and conductors to ground. That capacitance can increase the output current that's being seen on the drive. With smaller drives, a little bit of current that's being used to charge up those capacitors can be a big deal on a 1 horsepower drive that already has only an amp or two of current available. You want to make sure that you take into account what that distance is and making sure that you're not using up your current just to charge up those capacitors. On larger drives, again, it's going to be a smaller proportion to the overall current rating. When you get up to a couple 100 horsepower drive, a couple milliamps to an amp of current compared to 350 amps, it's not going to seem like a whole lot, but it still can cause issues. So you want to take that into account. Switching frequency, again, that's the rate at which the output IGBTs are turning on and off. So you want to make sure that you're looking at, if I've got longer cable lengths, how can I help the installation by maybe going to a lower switching frequency, going down to 2 kilohertz or 4 kilohertz. Because if you're going at higher switching frequency, again, those IGBTs are turning on and off at a higher rate. You've got the possibility for more spikes that can occur. Also take into account EMC standards. They're going to have different cable lengths that you're going to be allowed to go. If you see in our user manual, we'll give you a cable length on the output for regular installations and then those that have EMC requirements. And then also the motor windings, things like reflected wave or the DVDT that can occur. What you're going to see there is as you get longer cable lengths, you've got a potential for voltage doubling to occur and get higher peaks at the motor terminals that can potentially damage the motor windings. So you want to make sure that you know the motor type. Is it an inverter duty rated motor? Does it meet the NEMA MG1 standard for voltage peaks as well as the rise time that can occur? So you want to make sure that you're looking at, is that motor adequate enough to handle that? If not, looking at, do I need to add an output reactor? Do I need to add a DVDT filter? Or even a sine wave filter for greater distances? So I talked about that checklist that we have available. Again, something you can use, you can stick in your toolbox or in your engineering folder when you're going through and selecting things to take into account. Running down the mechanical checks, take into account the altitude. The humidity. Do I need to add a air conditioner? Do I need to add a dehumidifier? Take into account the ambient temperature around the drive. Again, make sure you take into account around the drive, outside of the enclosure. Is it too cool or too hot? Make sure you take into account both of those. Do I need to add a strip heater in the bottom to make sure it's adequately heated up before using it? Am I providing adequate cooling? Do I have enough airflow through the cabinet? Do I need to add additional fans? The enclosure type, is it mounted in an area that's going to be full of dust or debris, or is it mounted in a washdown environment? Do I need to have a 4X type drive? Is it going to be mounted outdoors on a rooftop? Do I need to take into account sun loading and sunspots? Mounting surface is appropriate. Again, making sure on heavier drives you've got a good solid backing to mount it to. Spacing and orientation of the drives, making sure you provide adequate cooling around them, as well as is it orientated in a vertical manner. Looking what's around that installation as well, making sure there's not devices that are adding excessive heat to the bottom of the drive. Vibration appropriate, taking into account where it's being mounted, what it's being mounted on, how it's going to be used. Taking into account electrical considerations, the drive connections within the cabinet, the input power, the transformer it's being connected to, the control voltages that I'm being used, is there a PLC involved, things like that. Feedback devices that are encoder or attack or resolver, making sure you're providing good signal strength back to the drive and it's not being injected with other noise from other devices in the plant. Your motor connections, take into account the cable length, the cable type. Also, along the lines with cable, is it being installed in a place where it could be run over with a forklift? Is it a watery environment or oily environment? Things like that need to be taken into account. Then looking at the mechanical checks, the motor mounting, feedback devices mounted securely on the motor. Do I need to decouple or can I leave it coupled up when doing an ID run? Those are setup features within the drive to make sure that the drive is, again, tuned to that motor. Things like that need to be taken into account. Thank you all for coming. Enjoy the rest of your day.